Hello there. In this lesson, we will be looking at powers of 10 and the scientific notation. Another name for the scientific notation is standard form. Powers of 10 will help us. Now, part A. Write the value of 10 to the second power. What is the value of 10 to the second power? Well, 10 to the second power can be written as 10 times 10, correct? Because the power here indicates that we'll be multiplying 10 by itself. And so we'll have two factors of 10, 1, 2. And that's what the power here indicates. So 10 times 10 means we're adding 10 10 times. And if we do that, we will get 100. 10 to the fifth power simply means that we are multiplying 10 by itself. How many factors do we have? 1, 2, 3, 4, 5. Indicated by the power of 5 here. So this number in the top right is known as the power or exponent or index. Now since we have 1, 2, 3, 4, 5 factors of 10, this will give us 100,000. And if we look at the number of zeros that we have, it will correspond to the power. Just like we have 10 to the second power, the two corresponding number of zeros. So 1, 2, 3, 4, 5 zeros, we have a power of 5. And so 10 to the power of 8 will give us what? 1 with how many zeros? 8, correct. 1, 2, 3, 4, 5, 6, 7, 8. Now, let me just write this over. So we're going to have 1, 2, 3, comma, 1, 2, 3. So that's 6 so far, 6 zeros, comma, 7, 8 zeros, and then we put our 1. So that's 100 million. We have 1 with 8 zeros. Now your turn. Attempt part 4 and 5 of part A. What is your answer for 10 to the first power? What is your answer for 10 to the third power? Place your answers in the comment section. Now let's look at part B. For part B, we're asked now to write these ordinary numbers as a power of 10. 100. What power of 10 is 100? Well, since 100 is 10 times 10, it means that we'll have two factors of 10. So the power is 2. So 10 to the second power is our solution. What about 10 million? How do we write this number as a power of 10? So we have 1,000, then we have 1,000, and 1,000 is a million, and so we have 10 million. All right, how many zeros do we have? 3, 6, 7. We have 10 with 7 zeros. So it implies that a million will be 10 with 6 zeros. So we'll have 10 to the 6th power in that case. Let's look at number 3, 1,000. How many zeros do we have? 3. So that means we'll be multiplying 10 by 10 by 10. And so that's 10 to the third power. Did you get that? Well, I would like you to attempt part 4 and part 5. Place your answer or answers in the comment section. Now let us look at the next part, part C. Write as a basic numeral 2 multiplied by 10 to the 5th power. Now of course, 2 multiplied by 10 to the 5th power is simply 2 times, and the 10 to the 5th power can be written as 1 with 5 zeros. 1, 2, 3, 4, 5. So that's 2 times 100,000. And of course, we will simply multiply the 2 by the 1 to get 2 and put back the zeros. So that's 200,000. 100,000 multiplied by 2 is 200,000. 3 times 10 to the third power is 3 multiplied by we have 10 to the third power, so that's 1,000. So that's 3 times 1,000, 1 with 3 zeros. And 3 times 1,000 is simply 3,000. Let's look at the next one. 4 times 10 to the first power. Oh, that's simple. So that will be 4 times 10. The power of 1 simply means that we'll have 1 0. And so 4 times 10 will simply be 40. 1 times 10 to the first power will be what? I mean, that is very simple. What do you think that answer should be? Well, that will be 1 times 10. 10 to the first power is simply 10. 1, 0, indicated by the power of 1. And 1 times 10 will give us 10. Now, let's write the value of 400 as the power of 10. Well, in 400, we have what? We have 4 times 100. Since we're talking about powers of 10. 400 can be written as 4 times 100. And we know 100 can be written as what? 10 to what? The second power, correct? So we can write this as, writing back the 4 times 10 to the second power. Since 100 can be written as 10 times 10. And 10 times 10 can be written as 10 squared. So this will be our answer. Let's try 20 million. Now, of course, this can be written as 2 times how much? 10 million. Because 2 times 10 million is 20 million. And so this can be written as 2 multiplied by 10 to what power? Well, how many zeros do we have? 3, 6, and 1 makes 7. So 2 times 10 to the 7th power. Now, what about 80? 80 can be written as 8 times 10. And so we'll say 8 times 10 to the 1 power. What about 9,000? And what about 300,000? Please share your answer in the comment section. And of course, I'll indicate whether you're right or you need to try again. Let's look at the next one. Write in decimal form. Now, let me just clarify something. 10 to the negative second power. Here the power is a negative number. So what do we do? Well, here's a little explanation that I can use. 10 to the second power, when it's a positive power, is 100, correct? So if we think of it as starting from 1, and we have second power, we move the point 2 places to the right. So if it's negative, if we start from 1, we move the point 2 places to the left. And so it will be 0.01. So 10 to the negative 2 power will be 0.01. Let's look at the second one in a similar manner. 10 to the 5th power. We can think of it as 1 multiplied by, well, let's see again. We can think of it as 10 multiplied by itself 5 times. So, but let's look at it a different way. We start with 1, and we're going to move the decimal point 5 places to the right. 1, 2, 3. So we were here. 1, 2, 3, 4, 5. And then we'll insert some zeros. 1, 2, 3, 4, 5. And so we're seeing that this will be 1. And we have how many zeros? 1, 2, 3, 4, 5. 5 zeros. That's another way to look at it. So now, if we were given the opposite of 10 to the 5th power, which is 10 to the negative 5th power, what direction would we go? Instead of going to the right, we'll go to the left. So let's do the same thing here. So we start with 1. The point is here in 1, of course. You put 1 in your calculator, you see the point at the end here, right? And we're going to go 5 places to the left, indicated by negative 5. So 1, 2, 3, 4, 5. And we're going to put some zeros as placeholder there. So we're going to put 0. So remember the point is right here. So 1, 2, 3, 4. And then before the point, we're going to have a 0 here for the whole number position. Decimal places, we'll have 1, 2, 3, 4, 4 zeros after the point. So that's going to be 0 point, and we have 1, 2, 3, 4 before the 1. 4 zeros before the 1. Following the point. Alright, so now let's try the third one. And then we're going to come up with an idea of how to make this much easier for us to do. 10 to the negative third power. So let's look at that. Again, we start with a 1. The point is right here. And we're going to move how many places to the left indicated by the negative 3? 3 places. 1, 2, 3. 3 places to the left. So the point is right here. And you always want a 0 there before the point. We're going to put 1, 2 zeros where we have the little cells there. So we're going to have 0.001. Okay, let's come up with a pattern. Do you notice that we're raising 10 to the negative 2 power, correct? So to the left of the 1, look at how many zeros we have. We have 2 zeros to the left of 1. Of course, we have a decimal point between the first 2 zeros there. Okay, same thing for number 2. 10 to the negative 5th power. We have 1, 2, 3, 4, 5 zeros. 10 to the negative 5. Or 10 to the negative 5th power. And we have to the left of the 1, 1, 2, 3, 4, 5 zeros, including the 0 that has the point after it. 10 to the negative 3rd power. How many zeros do we have prior to the 1? 1, 2, 3, including 0 with a point after it. So 10 to the negative 8th power, what will that be? Okay, so we're seeing we have 2 zeros before the 1, 5 zeros before the 1, 3 zeros before the 1, so we're going to have 8 zeros before the 1. So we're going to start 1, 2, 3, 4, 5, 6, 7, 8 zeros before the 1. And let's see, if we have to move the point to the right, 1, 2, 3, 4, 5, 6, 7, 8 before we get back to 1. 1, 2, 3 before we get 1. 1, 2, 3, 4, 5 in order to get 1. 1, 2 in order to get 1. And so 10 to the negative 1 power will be what? Well, since we have a negative 1, we need 1 0 before we get 1. So that's going to be 0.1. And again, we need to move only 1 place to the right to get 1. So let's strengthen our understanding with this other one. So this one was part D. This was part E. And we're now with part F. 3 times 10 to the negative 5th power. So again, we can think of this as 3 times, and then we can rewrite this as a decimal, 0.0001234 5 zeros. Then we have our 1 there. So 3 times this will be simply 0.123, 1, 2, 3, 4, 5. And 3 times the 1 here will be 3. Because we need to multiply this 3 by only 1. Because these are zeros, and of course 3 times 0 will be 0. So this will be our solution. Let's look at okay, so we have these numbering issues there. Alright, so that was part 1. Part 2, 4 times 10 to the negative 3rd power. That will be 4 multiplied by the decimal 0.001. How many zeros should we have before the 1? 1, 2, 3. And 4 times 1 here would be 4, so 0.004. The next one is 2 times 10 to the negative 1 power. So that's 2 multiplied by 0.1. Remember with negative 1, only want 1 0 before the 1 here. And 2 times 1, this one here is 2, so that's 0.2. And the last one, 1 times 10 to the negative 1 power, so that's 1 times 0.1. And 1 times 1 we know is 1, so it's still 0.1. Hope that was clear. Okay, so this is the part you've been waiting for. Right inside of notation, 1,720,000. All right, so how are we going to do this? 10 to the 6th power. What times 10 to the 6th power will give us 1,720,000? Now, when it comes to scientific notation, we need the first part to be a number between 1 and 10. So let's say we call this first part A. A here has to be a number between 1 and 10. So it must be greater than or equal to 1, but must be less than 10. So any number in standard form, we have A must be what? Greater than or equal to 1, but less than 10. That's very important. So how are we going to do this? So the point is at the end here in this number. All right, and as long as we're trying to count backwards, we need to get this number here. We need to get this first number here as a number between 1 and 10. So we need to shift this point to a position where this number is now a number between 1 and 10. Only after the 1 or between 1 and 7 can we shift that point to get 1.72. Putting the zeros at the end here would not matter because 1.72 and any zeros after will be the same as 1.72. But now, multiplying by 10 to the 6th power, would that be accurate? Let's see. If we want to multiply 1.72 by 10 to the 6th, it means that we have to shift the point 1, 2, 3, 4, 5, 6 places to the right to get back the original number. Again, multiplying by positive power of 10, we'd have to shift this point 6 places to the right. So between 1.7, we have 1, 2, 3, 4, 5, 6. What about the 68,000? Well, times 10 to what? 10 to the 4th power. So the point will have to be where in order for us to get 10 to the 4th power? Well, let's see. Reversing the process, we'll have 1, 2, 3, 4. So that will be 6.8 as a number between 1 and 10. 6.8 is definitely between 1 and 10. That's the A portion. Multiplied by a power of 10. And let's see, if we move the point from where it is in this original or ordinary number, our basic numeral, and we shift it between the 6 and the 8, notice that we have 1, 2, let's see, we have 1, 2, 3, 4, 4 digits between the 2 points, the original point and where we shifted the point to. So between these 2 points, we have 1, 2, 3, 1, 2, 3, 4. 4 digits, hence the 4th power. Let's try the next. 8,580 can be written as 8.58. So correctly, it's between 1 and 10, a number between 1 and 10. So where was the point originally? The point was here. And it was shifted between the 8 and the 5 for it to become a number between 1 and 10. How many digits do we have between the original point, where it was originally, and where it is now? 3 digits. So that's 10 to the 3rd power. In other words, when I multiply 8.58 58 by 10 to the third power, the point is shifted 1, 2, 3 places to the right to give me back the original number 8,580. So again, the point is here, so we think of it as being here as 8.58. And we'll multiply it by 1,000, or in other words, 10 times 10 times 10, or 1,000 is shifted 1, 2, 3 places to the right. And I'm sure you can think of this like an ordinary number that you have. Let's say we have 7 times 10 to the third power. That means 7 times 1,000. And so in the number 7, we shift the point 3 places to the right. 1, 2, 3. So that number becomes 7,000. And we know 7 times 1,000 is 7,000 indeed. So that's the case. Hope that helps a little bit. And if we go down to this one, 660,000, the point is after the first non-zero digit, right? So it's now a number between 1 and 10, as in 6.6. But to get back to the original number, which is gonna be what? 660,000, we'll need to multiply by what power of 10? So the point is right here, based on where they put it here. So we have to move 1, 2, 3, 4, 5 places to the right. So 6.6 times 10 to the fifth power will give us back 660,000. You can try it with a calculator. 6.6 times 10 to the fifth power should give us 660,000. If you want to reverse the process, points at n, 1, 2, 3, 4, 5. Alright, so let's look at the next one. 9,700 can be written as what times 10 to what power? Well, please place your answer in the comment section and label this one as G, part G. Alright, G, so you're going to label it G5. Okay, but what if we were asked to write as a basic number 4.5 times 10 to the fourth power? How would we do that? So we're going from standard form to a basic number. How would we do that? Well, 4.5 times 10 to the fourth power, we will need to shift this point how many places to the right? Based on the power of 4, we'll need to multiply it by 10,000, right? Because 10 to the fourth should have 4 zeros. And we'll need to shift this point 4 places to the right. So that's be 4. And this 5, this point here will shift once, 2 times, 3, 4 times. And then we simply enter some zeros to hold space or place value. So we'll have 4, 5, 1, 2, 3 zeros at the end. 4, 5, 0, 0, 0. Alright, so think of it again. The point is here. Move once, twice, 3, 4 times. 45,000. Now 6.718 times 10 to the third power. Again, we need to shift the point 1, 2, 3 places to the right. And so that will give us 6,718. 5.8. Alright, so we're converting this one into standard form. 5.8 times 10 to the fifth, and that's going to be 5.8 times 100,000. And again, we're going to shift the point the same number of places that we're seeing as the power. So when you shift it one place to the right, it takes off one of the zeros in a sense. And so we have 58. If you look at this, this would be like 1, 2, 3, 4 zeros, like 58 times 10,000, right? So that's 580,000. If you can't see it that way, it might be a little confusing. We can just go back to the original way we're doing it. And so that's going to be 5.8. And we're going to move how many places to the right? 1, 2, 3, 4, 5, indicated by the number of the power, right? So 1, 2, 3, 4, 5 places to the right. And so we're going to put these placeholders in here as zeros. And so the point is now at the end. So we have 5, 8, 1, 2, 3, 4. So that's 580,000. Okay, so if we look at the point being at the end, and we shift it 1, 2, 3, 4, 5 places to the left, it will be now 5.8. The zeros will not matter there, so it'll be 5.8 as we have here. I would have moved 1, 2, 3, 4, 5 places, so that's indicated by the power of 5. So why we move to the right though? Why did we move to the right? Because the power is positive, and of course the number should be greater than 5.8. So we move to the right. Now 1.1 times 10 to the 6. So that's the same thing as saying what? 1.1 times a million. So that's right, 1, 2, 3, comma, 1, 2, 3, comma. So that's 1.1 times a million. And so that will be what? 1, 1. Of course, in 1.1, we move in 1, 2, 3, 4, 5, 6. 6 places. So we'll have 5 zeros. After we move once, we have 5 more places to move. 1, 2, 3, 4, 5. So our answer should be 1, 2, 3, 4, 5. And so our answer will be 1,100,000. What do you think the answer for this one will be? What should the answer for this one be? Alright, so you can put this in the comment. Put your answer in the comment. That's going to be part H. I'm looking at number 5. Part H5. Let me know what is your solution to this one. Okay, so we're at the last part. How do we write this in scientific notation? 0.00095. How do we write it in scientific notation? Notice we've been given some help. We have 10 to the negative 4th power. And of course, it should be negative 4th power. If you look at the number of zeros, 1, 2, 3, 4. Look at the number of zeros in part 2. Alright? And this is I. Part I, number 1. Number 2. 1, 2, 3, 4, 5, 6 zeros. So negative 6. And that makes sense, right? But remember, the first part should be a number between 1 and 10. So we want to shift this point until we now have a number between 1 and 10. And that's going to be 9.5. 9.5 is a number between 1 and 10. And why multiply by a negative 4th power? Because we're moving to the left. So go 1, 2, 3, 4 places to the left. That's how we end up with 0.00095. This one, we're going to shift the point until we have a number between 1 and 10. So it's going to be 8.21. What do we do with all these zeros? Well, it would not matter in this case because all these zeros, if we put some zeros at the beginning here, once we put a point between 8 and 2, the non-zero digits, the zeros before the 8 will not matter. Alright, in fact, this number here, 8.21, when you multiply it by a negative power of 10, we shift in the point to the left. And so to the negative 6th power will be, go 6 places to the left, as we here, right? So we really here, go 1, 2, 3, 4, 5, 6. So we'll end up back with this number, 0.0000821. Alright, so let's go down to the next example question. 0.0087 it can be written in standard form or scientific notation as what? Again, we need to have a number between 1 and 10, so you go between the 8 and the 7. The point moves between the 8 and the 7. As we can see here, I'm going to multiply by power of 10. So we would have shifted 1, 2, 3, 3 times. So the 3rd power of 10. But should it be positive or negative though? Well, it cannot be positive. Why cannot it be positive? Because if we have 8.7 times 10 to the 3rd power, it will be 8.7 times 1,000. which means we're shifting the point, to the right. And we do not want a number greater than 8.7. We need a number less than 8.7. All right. And so if you look at this is what we have, 0.0087, which is much less than 8.7. It's less than 1 actually. So when the number starts with 0, the power should be what? The power should be negative. All right, the power should be negative. Very good. And so this will be written to the negative 1, 2, 3, third power. All right, I'm going to do part 4, and then you will do part 5 of part I and put it in the comment section, right? You're going to do this one in the comment section. So let's look at this number here, 0.0000219. Well, remember, in standard form or scientific notation, the first part should be a number between 1 and 10, as we have here. Multiply by a power of 10. And so, when we shift the point from here and put it between 2 and 1, it's now 2.19, which is a number between 1 and 10. In other words, we want to shift this point until we get it after the first non-zero digit. And the first non-zero digit we have is 2. So the point must go after that first non-zero digit. Like the point shifted here after the first non-zero digit, so we have 8.7. And the same thing goes for here. So we have 2.19 times what power of 10? Well, how many places the point moved or shifted? 1, 2, 3, 4, 5, 6. And must be negative. Why negative though? Well, if you look at it, the original number starts with a 0, and so we're going to have a negative power. That's one way of remembering. But it must be negative 6, so that when we multiply this 2.19 by 10 to the negative 6, we actually reversing the process back to the left, shifting to the left. I mean, that's one way of looking at it. All right, because there's actually another way of looking at these negative powers of 10. For instance, 10 to the negative 6th power can be thought of 1 over 10 to the 6th power. And so I multiply this by 2.19, it ends up being 2.19 over 10 to the 6th power. In other words, 2.19 over a million. 1, 2, 3, 4, 5, 6. When you divide 2.19 by a million, you end up with this. All right, this number here. All right, so when you have a negative power of 10, you can write it as a positive power of 10 by putting 1 over 10 to the 6th power. Like, for instance, this could be written as 8.7 times 1 over 10 to the positive 3rd power. And so you'll get 8.7 times 1 is 8.7 over 10 to the 3rd power, which is 8.7 over 1,000. When you divide 8.7 by 1,000, you'll get back this number here. That's probably more clarity, a little bit more clarity. Yes, that will provide a little bit more clarity than the other ways I've just showed you. All right, but still, it's a quicker method of just shifting the point. So remember, you're gonna try this one in your spare time, and remember to post your answer for this one in the comment section. All right, so let's look at the last question now. 9.5 times 10 to the negative 4th power. So we're moving from scientific notation to basic number. 9.5 times 10 to the negative 4th power. And then remember, we can actually write this as 9.5 times 1 divided by 10 to the 4th power. Put 9.5 over 1. 9.5 times 1 is 9.5. And we're going to divide that by 1 with 4 zeros. And so we're shifting the point 4 places to the left because we're dividing. And so that will be 0.000219. 0, 9, 5. Let's see. 1, 2, 3, 4. Alright, so this will be the answer. Again, if we have 9.5, we shift 1, 2, 3, 4 places to the left. Then we'll have the zeros here. And so it'll be 0.00095. So we'll have 4 zeros here. Next, 7.6 times 10 to the negative fifth power. Again, move the point 5 places to the left. So once we shift it once, take care of one of the power here. So we'll have negative 4 remaining. So we should have 4 zeros. And so that will be 0.123, 0.00076. Let me see if that's correct. No, that's not correct. Alright, so let's put another one. Let's do this over. So 7.6 times 10 to the negative fifth power. So we're going to write that down. 7.6, shift the point 1, 2, 3, 4, 5. And so we're going to put these zeros here. And so our answer will be 1, 2, 3, 4, 5 zeros there, including the one before the point, 7, 6. Alright, let's do this one. 9.8 times 10 to the negative third power. And so we're going to have 0.0098. 1, 2, 3 zeros before indicated by the power there. I'm sure you can actually do this these other two. Let me just do number part 4. So 5 zeros there. And then we're going to have 286. But let's double check to make sure. 1, if we shift in the point 1, 2, 3, 4. I think I put too many zeros there. Let's start over again. So that should be 0.1234. This will be 5 in total. 1, 2, 3, 4, 5 zeros. Now you have 286. And if we check back, we'll have, let's shift in the point 1, 2, 3, 4, 5 to get it as 2.86. Alright, so you can attempt this one. Hopefully my examples were clear.